Hello and welcome to Virtual CB1A. This is Ma'am Rena and this is week 1, lecture 1 of Logic and Set Theory. Today, we will discuss all about concept of sets. Let's start with the learning objectives. At the end of this week, you are expected to learn how to determine if a set is well-defined or not. Also, you should be able to represent sets using the tabular and descriptive method. Next, you should know the different kinds of sets and describe relationships between sets. And finally, you should be able to write the power set of a given set. So let's start with the definitions. A set is a well-defined collection of distinct objects. A set is often denoted by an uppercase letter. An element, also referred to as a member of the set, is an object or value that belongs to a set and is usually represented by a lowercase letter. Now, let's talk about some of the symbols that we are going to use in this course. This symbol here denotes membership, while this other symbol denotes non-membership to a set. Therefore, this expression, read as X is an element of the set S, means that X can be found on set S, while X, not an element of the set S, means that X does not belong to set S. Now, let's look at some of the examples. Determine if the following collection of objects is a well-defined set or not. First collection of objects, good students of PSBC. Let's analyze. Is it well-defined? Do we have all the characteristics in order for us to name the elements of the set? How about you? Do you consider yourselves as good? Okay. If we are only talking about students of PSBC, then it is a well-defined set. But with the addition of this characteristic, good, it makes our collection ambiguous. Therefore, this is not an example of a well-defined set. Let's have the next example. Besides students of PSBC enrolled in logic and set theory. Is this well-defined? Do we have all the characteristics in order for us to know the elements or members of the set? Yes. Therefore, this set is well-defined. Now let's look at the third example. The set of whole numbers less than 10. Do we have all the characteristics in order for us to know the elements or members of the set? Yes. Then this is another example of a well-defined set. How about this one? List of favorite letters. Whose favorite? Okay. Again, this word here, favorite, makes our collection ambiguous. Therefore, this is not a well-defined set. How about set of small numbers? How small should a number be for it to be considered small and become a member of this set? Ang hirap, di ba? Kasi hindi natin alam. Therefore, this is not a well-defined set. And finally, we have set of consonant letters in the English alphabet. Do we have all the characteristics in order for us to determine the elements of the set? Yes. Then this is a well-defined set. Now let's go to the ways of describing a set. There are two ways of representing sets. First is the roster or tabular method. This method involves enlisting all the distinct elements in the set, separating the elements by the use of comma, and then closing them with a pair of brackets. The second method is the rule or descriptive method. This method uses set builder notations. Oftentimes, we use the variable x to represent any element of the set. It is better to familiarize yourselves with symbols such as is an element of, equal, not equal, less than, greater than, less than or equal, greater than or equal, and this elongated L, which is read as such as, because this will be the symbols that we are going to use in the descriptive method. So this method describes the common characteristics of the elements. Let's have some examples. Example number 1. Describe the following sets using tabular method and descriptive method, the distinct letters in the word mathematics. How many elements do we have? Let's look at the letters in the word mathematics. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 letters. Are the 11 letters distinct from one another? No. If you will take notice, the words M, A, and T are repeated twice. So, if we are going to write this using the tabular method, we only have to write the letters M, A, and T once. Let's look at the solution. Let S be the set of distinct letters of the word mathematics. In tabular form, this is S is equal to M, comma, A, comma, T, comma, H, comma, E, comma, I, comma, C, comma, S, and then close with a pair of bracket. Andali, diba? Now let's go to the descriptive form. So we are going to describe the characteristic of the set using the set builder notation. So we will use the variable x as a representative of the distinct letters in the word mathematics. In descriptive form, this is S is equal to x such that x is a distinct letter of the word mathematics. Now, let's look at the next example. We have the set of whole numbers less than 10. We already defined this earlier. Now, let's look at the next example. We have the set of whole numbers less than 10. In tabular form, let B be the set of whole numbers less than 10. We have B is equal to, the first whole number is 0, followed by, comma 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, comma 9, and enclosed with a pair of bracket. For the descriptive form, again, we will use the set builder notation. But instead of using English sentences, let's try to use symbols. For the descriptive form, this can be represented as b is equal to x, such that x is an element of the whole number system and x is less than 10. Okay, if we are going to write this using the English sentence, this will be b is equal to, haba kasi x, such that x is a whole number less than 10. Okay, both of these are correct, but in logic and set theory, we prefer to use set builder notations, purely symbols lang. So please try to learn how to use symbols. Okay, that will be the end of, nagulat ako, end na pala yun. So this is going to be the end of lecture 1 of week 1. So stay tuned for lecture 2. I will send you a link on the Google Classroom. Bye!